In this lesson, we're going to be talking about the history of TCPIP, the network that eventually morphed into the thing that we now call the Internet began in 1969, and it spun out of this government organization called ARPA, which was the Advanced Research Projects Agency. They had an idea to create a computer network that was resilient to certain types of military attacks. And the idea was to have this network that would survive certain types of war and warlike conditions. So ARPA sent out this request for proposals, and BBN, which is Bolt, Beranek, and Newman, and they were previously an acoustical consulting company. They won the contract to build what was called the ARPANET. The first connection was in 1969. So that's where we get the idea that the Internet began in 1969. The Internet, as we call it now, didn't really begin in 1969, but the ARPANET did, and the ARPANET has a long history that goes through the NSF-net in the 1980s after the ARPANET was sort of decommissioned and a lot of other networks were folded into this thing called the NSF-net that then turned into what we now call the Internet once a lot of other networks were connected into it. First protocols on the ARPANET. Initially, there was the 1822 protocol, which was the very first protocol defining communications on the ARPANET, and it was called the 1822 protocol because of BBN Report 1822, which described how it worked. Shortly after that, there was this thing called the Network Control Program. And the Network Control Program consisted of ARPANET host-to-host protocol and an initial connection protocol. Now, there's certainly not a direct correlation or analogy here, but if you want to think about it in a particular way, you could say that the ARPANET host-to-host protocol is kind of like UDP, and the initial connection protocol is kind of like TCP. So the host-to-host protocol provided a unidirectional flow-controlled stream between hosts, which sounds a little bit like UDP. And the ICP provided a bidirectional pair of streams between two hosts. Again, these aren't perfect analogies, but the host-to-host protocol is a little bit like UDP, and the ICP is a little bit like TCP. Now, the first router was called an interface message processor, and that was developed by BBN. It was actually a ruggedized Honeywell computer that had special interfaces and software. So the first router wasn't a ground-up built piece of hardware. It was actually an existing piece of hardware that was specially purposed for this particular application. So Honeywell had this computer that they made, and BBN took that and made some special hardware interfaces and wrote some special software that allowed it to turn into this interface message processor, which passed messages over the ARPANET from one location to another. So where did IP come in here? Well, in 1973, a guy by the name of Vint Cerf and another guy by the name of Robert Kahn took the ideas of the NCP and what the ARPANET was doing, and they tried to come up with some concepts that would work for the needs that the ARPANET had. So by 1974, they had published a paper that was published by the IEEE, and they proposed some new protocols. They originally proposed a central protocol called TCP. Later on, TCP was broken into TCP and IP to get away from the monolithic concept that TCP was originally. So they broke it into more modular protocols, and thus we get TCP and IP. So how do we get to version 4? Since that's kind of where we are right now. Version 6 is coming and has been coming for many, many years now, but we're still kind of at version 4. So how did we get there? Between 1977 and 79, we went through version 0 to 3. And by 1979, 1980, we started using version 4. That eventually became the de facto protocol on the internet in 1983 when NCP was finally shut down because all of the hosts on the ARPANET were using TCPIP by that point. In 1992, work began on IP Next Generation, and for a long time, all of the specifications in the RFCs talked about IPNG. Eventually, IPNG became known as IPv6. You may be wondering where IPv5 went. Well, it was a specially purposed protocol that had to do with streaming, and certainly not a widespread thing. What are the differences between IPv6 and IPv4? Well, IPv6 has 128-bit addresses, which gives us the ability to have some ridiculously large number of devices that have their own unique IP address. IPv4, by comparison, has only 32-bit addresses, and as you've probably heard, we're well on our way to exhausting the number of IP addresses that are available, and we've done a lot of things over the years to conserve address space and reuse address space. And so we continue extending the point at which we just truly run out of IPv4 addresses. Another thing about IPv6 is it attempted to fix some of the inherent issues in IP. And some of those has to do with security concerns, and there are certainly a number of flaws in IPv4. And when they started working on the IP Next Generation or IPv6, they tried to address some of those concerns and some of those issues. And they may not have done it perfectly, but it was certainly an attempt, and IPv6 attempted to fix some of the issues that were inherent in IP. So that's a history of TCP/IP.